Let's look at another situation where we use that counting principle. Here we have, you got ordering the kids' lunch at Burger Universe. Customer must choose a size, whether or not to have cheese, a type of bun, side order, and a type of fruit drink. So we want to know how many possible choices are there. Different ways you could order those things. All right. So we've got either small or large. So there's two choices there. With or without cheese, two choices there. You could have a plain or sesame seed bun, two choices there. Fries or onion rings, two choices. And then you could have grape, orange, grape, cherry, lemonade, or mango. So there are 5 choices there. All right. So I'm gonna, the total number of possibilities would be 2 times 2 times 2 times 2 times 5. Okay, so if I type that in my calculator or do it in my head, that's gonna be 10, I think that's 80. 16, yeah. So there's 80 different possibilities there. And if I did before, like I could set up you don't want to have to do this. All right. So last type of that, but you want to do that. Problem here. It says, again, it's the counting principle. When ordering an ice cream, he must order a size, a flavor, and a topping. 2 sizes, 3 flavors, 2 toppings. All I'm going to have to do there is multiply those together to get the total for the number of different ice cream desserts he could order. 2 times 3 is 6 times 2. That's going to equal 12. 12 different possibilities. Now, let's look at this one below here where it's a little bit different, a little bit more complicated. We're talking about a company needs temporary passwords for the trial of new employee software. Each password will have 1 digit followed by 3 letters. The letter G and these digits will not be used. All right. So we know we're not going to use a G. We're not going to use those digits. So the question is, so there's 25 letters, 6 digits we're going to be using. Assume the letters can be repeated and the digits. How many passwords can be created using this format? So you're gonna, and it tells you each password is going to have 1 digit followed by 3 letters. Okay, so we got 1 digit followed by 3 letters. So so you're going to have digit and then a letter, and a letter. All right, so there are 6 digits. So there's 6 possibilities for that digit to be. And then I've got 25 chances for this letter, 25 chances for this letter, and 25 chances for this letter, because it says I could repeat them. I could repeat the same letter. So I could have a code like 7A. That would be one code, and I could have another code that would be 7ABC or something like that. But there's 6 choices here, 25 for each of these. To find the total number, I'm going to multiply those together and get my final answer for this problem here. Okay, pretty big number. I don't have my calculator, so you're going to have to do that yourself. All right, good luck with those. Again, this is setting up, all of this is just setting up probability for the next several lessons. All right, here we go with homework 3-4. We're going to be talking about probability for the next week or so. So here it's just kind of setting the basis for how probability works. In this case, we have a class who's choosing a president, a vice president, a treasurer. And there are 2 students running for president, Linda and Maria, 2 students running for vice president, Bob and John, and 3 students running for treasurer, Jessica, Amanda, and Deborah. And so what's listed here is just all the possibilities of what could happen. So we know Linda or Maria could be president, and then let's say if Linda's president, then she could have Bob or John as the vice president. And then let's just say if Bob's president, then these could be the treasurers. But it also could work this way. So you have all these are all the possibilities. This is called a sample space. And in this case, what we're doing here in the next few problems is just determining how many should be in the sample space. So in this case, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many outcomes are there? There are 12. And then how many outcomes have Amanda and Deborah being chosen? So I could go back through there and pick the ones with Amanda and Deborah. Here's, looks like there's 8 of them. And then how many outcomes have both Maria and John being chosen? So I could go back through there and pick the ones with Maria and John. Different color here. Looks like Maria and John there. And that's all Maria and John, right? So there's only 3 of those. So the thing to look for here, we're going to be talking about a counting principle, but if you'll notice that I had 2 chances for president. Well, let's do it up here. I had 2 chances for president, I had 2 chances for vice president, and I had 3 chances or possibilities for treasurer. If I were to multiply those together, that's going to equal the total number of outcomes. And that's basically the counting principle. All right, could set up a tree like we had in this example with each of the different possibilities and all the different branches. But by the time you finish, instead of having 12 like we did here, you'd have 80 branches.